Hi everyone, in this video we're going to be simplifying fractions. In particular, we're going to focus on simplifying algebraic fractions and fractions that have multiplication and division with powers. I'm assuming that you've done a bit of work with fractions before, so I'll be going through this quite quickly. As part of this video, I'm also going to discuss the first and second laws of exponents. Since in this video we're going to work with exponents, let's revise some of the terminology that's used around exponents. So firstly, what does a to the power of m mean? It means a multiplied by a multiplied by a multiplied by a, and that continues how many times? M times. Now we also use specific words for parts of the power. The m, that is called the exponent. Some people call that the index. So you might hear people call exponents indices. That's just a different name. Then the a itself, that is the base. And the whole thing, a to the power of m, is called a power. Let's discuss how to multiply and divide fractions. If I was to multiply a over b times by c over d, the way we multiply is you multiply the numerators together, and so that would give you AC in the numerator, and you multiply the denominators together, BD in the denominator. Before you multiply, it's often a good idea to simplify fractions so that you're multiplying an easier fraction. So you simplify fractions to make them equivalent. Let me give you an example of simplifying a fraction. So my example is 15a squared b divided by 10a. I'm going to simplify by dividing top and bottom by the same factor. The common factor is 5a, so I'll divide top and bottom by 5a. Because I'm dividing top and bottom of the fraction by the same factor, it's not going to change the value of the fraction, it's just going to simplify it. The way we show this dividing top and bottom by the same value is I cross out where I've divided. 10 divided by 5 is 2, and 15 divided by 5 is 3. A divided by a gives me 1, so I won't write down any a's. And a squared divided by a will give me a to the power of 1. So my simplified fraction here is 3ab out of 2. Let's look at a simplifying example with multiplying. So let's say I'm multiplying x squared y out of 8 times by 10y out of x cubed. Now if I multiply straight away, that's going to give me 10x squared y squared out of 8x cubed. Then I can simplify this by dividing top and bottom by my common factor, which will be 2, and 10 divided by 5 is 10 divided by 2 is 5, and x squared. So I'm left with x and no x's. So that simplifies to 5y squared out of 4x. Now if you want, you can save yourself some time. So a faster way, and it might not seem much faster in this example, but if your fractions were a lot longer, it would be better to simplify your fractions first and then multiply. Since I'm going to be multiplying all the numerators together and all the denominators together, I can simplify by removing common factors in any numerator and any denominator of the fractions being multiplied. 2 goes into 8 4 times, 2 goes into 10 5 times. X squared goes into there once, and I'm left over with x at the bottom. And so here I get 5y squared out of 4x. So it's definitely faster to simplify fractions before you multiply. Let's go on to division. So I'm sure in division you've heard the rule multiply by the reciprocal, but maybe you've never understood why. So let's think, if I had a divided by b, that is the same as writing a over b. And a over b is the same as a times by 1 over b, or let's say a over 1 times 1 out of b. So can you see it's equivalent to multiply by the reciprocal? The reciprocal is the inverse of what you have. It's the fraction upside down because b by itself is b over 1. So let's look at a couple of examples. Here's a general example. If I've got a over b divided by c over d, that will be a over b times by d out of c, which is the same as AD out of BC. Another example, let's say 9 out of x, it's a 9, not an a, divided by 3 out of x squared, that is the same as 9 out of x times by x squared out of 3. I'm now going to simplify before I divide. 3 is a common factor in top and bottom, and x is a common factor in top and bottom, or in numerator and denominator. So to finish off, I'm going to get 3x over 1, which is the same as 3x. You need to be careful when you simplify fractions. It's fine to simplify fractions when you're multiplying or dividing, but if you're adding or subtracting inside the fraction, or adding two fractions together, it's a little bit different. So if you look at the first example, that means the same as 4a out of a plus a squared b out of a. Each term in the top is divided by a. And this can be simplified to 4 plus ab. However, in the second fraction, you can see that you don't have y in both terms. So I could write this as 5x squared out of y minus y out of y. And then this could give me 1. But I would say that this is actually no simpler than what I started with. So I'd maybe say in its simplest form already. Let's look at the last example. I've got two factors in the numerator, 4 times a plus b, and in the denominator I've got 8 times a. So I can divide common factors. I can work with common factors. So 4 and 8 are being multiplied in the top and in the bottom, and I can divide each by 4. But the a is part of the bracket, and I've got a plus b in the bracket, so I can't divide just the a. So the simplest I can make this fraction is a plus b out of 2a. Now you might have heard of the laws of exponents before, and maybe you haven't. However, I'm pretty sure in your work with algebra so far that you've used them. So let's look at the first one. It says a to the power of m times a to the power of n. Let's see, what does that mean? It means a times a times a times a m times by a times a times a times a times a n times. So altogether, that will be a times a times a times a times a. How many times? M times plus n times m plus n times, which can be written as a to the power of m plus n. A to the power of m plus n. So an example of this law, using values that might be a bit more familiar with you, is a to the power of 3 times a to the power of 2 will be a to the power of 5. So in summary, when multiplying powers with the same base, you can add the exponents. So the important thing is you need to have the same base, and then you can add the exponents. The next law of exponents refers to dividing. Now, if you think about this, that would be a times a times a times a times a, m times out of a times a times a times a n times. So to simplify this fraction, you'll be dividing numerator and denominator by the same factor, which would be a. And how many a's would be left? Surely the difference between the number of a's in the numerator and the number of a's in the denominator. So a to the power of m divided by a to the power of n is a to the power of m minus n. Let's quickly look at an example. So if I had, for example, b to the power of 10 divided by b to the power of 4, 10 minus 4, b to the power of 6. So in summary, when dividing powers with the same base, so we're dividing powers with the same base, you can subtract the exponents. So we've covered what is known as the first law and the second law of exponents. A nice way to think of the laws of exponents is as shortcuts. The laws of exponents are shortcuts to help you to work more quickly. If you don't use the laws of exponents, working out will take a really long time and you won't be very efficient. I'm going to finish this video by doing some examples. The first example has two fractions multiplied together. If you look carefully, you'll see there's no way I can simplify these before multiplying. So in the numerator, when I multiply 5 by -1, I'm going to get -5. A squared times a cubed is a to the power of 2 plus 3, 5, multiplied by c. In the denominator, 2 times 8 gives me 16, and b to the power of 1 times b to the power of 4 is b to the power of 5. Can you see here, both in the numerator and in the denominator, I used the first law of exponents, where I multiplied values with the same base and I added their exponents. The second example just involves simplifying a fraction. So let's first look for common factors. 7 goes into the denominator once, 14 goes into the denominator twice. So far, my fraction will have a 2 in the numerator. Next, let's look at the variables. Now I've got a squared in the numerator and a in the denominator. So if I subtract my variables, 2 minus 1 gives me a in the numerator. Then I've got b to the power of 3 and b to the power of 5. And if I say 3 minus 5, I get -2. Now we're going to chat a little bit more about negative exponents in the future. Rather, I just prefer to think, does the numerator or the denominator have more b's? At the moment, there are more b's in the denominator. So I will end up with, instead of saying 3 minus 5, let's say 5 minus 3. With b's in the denominator, 5 minus 3 is 2, because I'll end up with more b's in the denominator. The next question involves dividing fractions. But before I even get to the division, can you see the first fraction can be simplified a little? 5 can go both into the numerator and the denominator, twice into the numerator and 7 times into the denominator. So I get 2p squared q cubed out of 7, and I'm going to multiply by the reciprocal, 14 in the numerator, p to the power of 5, q to the power of 2. Now let's simplify if I can. I can take 7 out of the numerator and the denominator. So far I know that my numbers are going to be 2 times 2 is 4 in the numerator. Next, let's look at our variables. P squared in the numerator and p to the power of 5 in the denominator. Since there are more p's in the denominator, I know that I'm going to end with p's in the denominator. So 5 minus 2 is 3 p's in the denominator. And the q's, I've got q to the power of 3 in the numerator, q to the power of 2 in the denominator. I'm going to end up with q's in the numerator, and 3 minus 2 is 1, and I'm not going to put the 1 there. Last question. 9mn cubed out of negative q to the power of 4. Now at the moment, I'm dividing by a whole number. And that whole number would be the same as negative 18m cubed n squared out of 1. So to multiply that by the reciprocal, it will be 1 out of negative 18 m cubed m squared. So let's first consider our signs. I've got a negative times by a negative. My answer is going to be positive. Next, let's see if I can simplify it all. 9 goes into the numerator once, and 9 goes into the denominator twice. So I know that in my denominator, I'm going to be dividing by 2. Next, let's look at my variables. I've got m and m cubed, so I'm going to be left with m squared in the denominator, and n cubed in the numerator, n squared in the denominator, n to the power of 1 in the numerator, and finally that q squared sitting there minding its own business, and it's still going to be divided by, not q squared, sorry, q to the power of 4. So to finish up, here's some tips to help you. Firstly, simplify first, if you can. Another tip is for dividing, you're going to multiply by the reciprocal. And a third tip for multiplying is often it's helpful to multiply signs first, then numbers, then variables. So that little combination of letters, S stands for signs, N stands for numbers, and V stands for variables. And this will work when you are multiplying things together.